Okay, we are live. Maybe let's start with Ben and then go up.
Hi. Yeah. I'm sorry. I didn't quite understand how that link, the notebook thing works. But I can, give you some explanation on, Ethereum's execution layer and how it differs from other things, at least that I'm aware of. So Ethereum's execution layer is in some senses simpler than Bitcoin's, but in some senses more complex. Simpler in the sense that, unlike Bitcoin, which can have sort of very complicated transactions, Ethereum transactions are actually very simple. They're just sort of like a single account, sort of like a single address, signing, targeting one thing, and calling one set of predefined data. So there's almost like a simple call function. The complexity of Ethereum comes from what they can call. So you can create a call, you can call basically arbitrary code, which can do arbitrary things. Whereas in Bitcoin, the transactions themselves are much more complicated. They have, what's called the UTXO structure. I'm not going to go into the details of that, but basically, they can sort of almost like have multi-account calling, where a certain number of input accounts becomes a certain number of output accounts, and each of these things can have its own sort of set of little code being executed. What it lacks is some way to like store things outside of this UTXO set. And the UTXO set is like this fundamentally transient thing where every time you call it, it has to be destroyed and regenerated. Um, Whereas Ethereum is much more long-lived, even though its transactions are much simpler. There's long-lived smart contracts and state functions, so that you can just call them repeatedly and they can save data and come back to it later. But yeah, Ethereum's execution layer is basically just, making blocks and calling these transactions and executing the code. And its simplicity is one of the reasons why I think it, and in fact, it was one of the first. Well, not quite the first, but one of the first sort of smart contracting chains. EVM and the Ethereum execution sort of contract structure became very widely used. I believe Solana uses something slightly different. I haven't looked into the details, but I believe that their structure is different. Um, but other than that, like even most competitors end up using or being what's so-called EVM compatible, so that contracts or whatever on Ethereum could be just copy pasted into a new chain and executed that way without having to deal with making sort of rewriting everything, which of course saves a lot of work. Um, yeah. Um, I'll pass it up to Anraj.
Yeah, so I mostly was exploring the EELS team in the lecture from the lecture. So it seems like it's basically a translation of the yellow paper where they've implemented everything in Python. And unlike the consensus spec, they first write Python and generate documentation from the Python code. And I think it for the consensus it was something opposite. So they have written something in like markdown documentation, and they use some tool called PySpec to generate the Python code. So here this team does it in the opposite way. I don't know the reason, but yeah, so like that was like what does that that's what the eels team basically is doing. And then but yeah, the Python implementation just makes it easy to like prototype stuff. Well, like I think a lot in Python. So basically, like he showed how to change the opcode, and if you want to introduce a new opcode into the EVM, you could just basically copy some code and make it change here and there, and then like it was easy to understand. That way, it's like this implementation at least gives a good prototyping platform. Uh, yeah, and then like and the lecture also mentioned that the yellow paper lags behind the actual implementation by one or two folks. So I don't know, like, does anybody still use the yellow paper, and like who is maintaining it, and what is the use of it? I'm not able to understand. And yeah, so those were some initial thoughts. Passing on to Venkat.
Yeah, this was an interesting format for the discussion since you just handed us a notebook LLM link with no indication of where to start, but it said there were 19 sources or something. Uh, so the first thing I did was ask for an overview of the sources, and that was pretty interesting. It gave me, I guess, the equivalent of a table of contents for like a book length thing. So the difference from like reading a single essay versus this is you can like dive in pretty random places. So uh, it gave me, if you try that prompt, it'll give you something like, I guess, a bullet list of about 20, 25 points or so. At least that's what it gave me. And so I just started picking up on different points to ask about. And the first one I asked about was the point that every block actually contains a Merkle root of the entire world state. So that struck me as interesting. So I was asking about what are the advantages or benefits of that, and uh, when does the Merkle root of the entire world state change, and so forth. So that was kind of interesting. I didn't fully understand the answer, but a related point that came up was somewhere in the bullet points, it also said that um, the entire protocol state is saved in a single folder after every hard fork. So this gets at one important implementation difference between using the yellow paper and eels, which is that if you're trying to make a change to the code and it needs to be like backward compatible across lots of forks because it's touching old transactions or whatever, if you're working with eels, apparently you can just go to the single folder right after the most recent hard fork and use that as the basis for everything you do. Whereas if you were implementing with respect to the yellow paper, you would need to have a lot of conditional logic. I didn't quite understand this point, but apparently that was one of the big motivations, is that to make the same change using the yellow paper, you'd need to write huge numbers of conditionals, whereas if you make it using eels, you just have to base it off one folder of code that's a complete snapshot of uh, uh, I guess a validated state of the protocol. So yeah, I agree with Anuraj that if this is the case, then the yellow paper, it's not clear who it's for or what its function is. Uh, but possibly this is purely a hypothesis. It could be that since the actual protocol evolves by people proposing EIPs, it getting accepted, and then it gets implemented and goes through certain levels of testing with testnets and devnets and so forth, and then becomes part of the main protocol. The evolution of the actual code base is always like one step at a time. It's a differential incremental evolution, which means, I suppose, that if people don't periodically take a look at the consistency of the whole holistic state of the protocol, um, weird errors might creep in. So that might be one reason why it's useful to keep something like the yellow paper as a full formal description of the whole thing updated, because that way it's basically a second level checking of the consistency and rigor of the protocol. That's at least my guess at why they do this, because I guess I'm also old fashioned enough that I do make a distinction between code that seems to run correctly on test data and you look through it and it seems correct as a parsing thing. Maybe it passes validation checks or something, but that's one kind of like rigor testing. Another kind is you're describing a system using equations and proving theorems about them. That's another kind of testing. And I've done a little bit of both types, and I'm not convinced in practice they're the same thing. I do think stating the description of a system mathematically and proving theorems about it gives you a somewhat higher level of rigor. But this is like a loose, I guess, vibe-based feeling on how you actually do rigorous checking of technical thing. Anyway, I didn't quite get into the EVM part or talking about EVMs, but after Ben shared his thoughts, I did ask about the high-level differences between the Bitcoin and Ethereum approaches to execution, and I agree. So the trade-off I think is Ethereum's simplicity at the transaction level comes at complexity at the state level, right? So you do have to maintain this full world state hash and that kind of thing in order to make transaction level mechanics much simpler. Whereas Bitcoin, I think, since what you're seeing is kind of like the residual balance front, it's like a wave front of residual balances that's propagating. It means to reconstruct something like the equivalent of the Ethereum world state, you'd actually have to go through a fairly non-trivial process of like backtracking and reconstructing the state, which I expect is one of the reasons Bitcoin doesn't evolve as fast. So there's other reasons. One of them is cultural. The Bitcoin people don't want their protocol to change or evolve much at all. But another technical reason might be it's set up so that it's actually hard to evolve the protocol because of factors like this. Anyway, so that's what I had. Back to the group since Jenna seems muted.
Yeah, the cultural difference between Ethereum and Bitcoin seems like really in contrast with each other. I think Bitcoin came up with some new node, V30 or something, and some people are like aggressively pushing not to upgrade to it. It was just so it's like a lot of people just don't want the protocol to change, it seems. More thoughts? More thoughts? Any more thoughts on the format itself, like using Notebook LM? How did it feel, or like was it useful or not?
I think a good practice would actually be to, once you load up the sources in a notebook, before sharing it, start with a couple of universal prompts that everybody would find useful, like the one I used to get started, which is provide an overview of all the sources. That way, you have like a map to start with, or something similar, like provide an executive summary or something to read, so you can start from somewhere, not a blank sheet.
Yeah.
But otherwise, yeah, I think this format works. It's a good way to load it up. And this is actually interestingly different from ChatGPT because ChatGPT doesn't share uploaded sources, which means you can't actually continue the session as is. It's useless to share a document session in ChatGPT. Here, it looks like it's useful.
More thoughts? If not, then we meet in 2 weeks. Thank you.